All right, well, welcome back, folks. We're just looking at tessellations today and what tessellations are. Quite a fascinating topic to go through. So let's look at what a tessellation is. Flat surface that goes on forever in two different directions. So, or just it goes on forever. You could just imagine like your wall or your floor, things like that is a plane, like it's one surface. A tessellation is something that tiles that plane, which means it puts physical tiles on the plane that you're looking at. Now, what we want with no gaps and no overlaps, and all the shapes are congruent, meaning all the shapes are equal. Uh, Congruent means that they're the same size, same shape. Where similar, it could be the same shape, but the size changes. Congruent because the shapes are identical the plane entirely. So if you look at your a brick wall, your flooring tiles, those are all examples of tessellations. And this last line here saying that degrees around the vertex must equal 360 degrees in order for a shape to tessellate. Well, we're going to look at that and why that's important uh, in a little bit. So let's look at some examples of tessellations here. Our first example is, let's close this because my computer is being really slow. A bunch of tiles here. This is an example of a tessellation, a brick wall where we have a rectangle over and over and over again. This is not a tessellation, this octagon, because there's overlap here, right? And we don't want overlap. We want it to fit together perfectly and look nice. So this would be an example of a non-tessellation. So next is where we look at octagons now, and we see these octagons as well as they're with these squares, and it looks like it's tessellated in the plane. The whole plane is covered, but you might say there's these square gaps. But you could use more than one shape, so two congruent shapes, so one shape mixed with another shape to tessellate the plane, and in this case, this is a tessellation. We look at a pentagon. Pentagons cannot tessellate the plane. As we look at this, we see that there's a gap here. We don't want any gaps, right? You can't fit another same size congruent pentagon in that gap, so we're not going to be able to tessellate this shape. There are three main types of tessellations we're going to look at. The first one is a regular tessellation, which means there's one shape, one polygon, regular polygon that tessellates the plane. Regular polygon is just means all the sides are equal, right? All the sides of this triangle, square, and hexagon are all equal, and then they're going to tessellate the plane. So there we go. We got a regular tessellation. Semi-regular is when we have a pattern of two or more shapes put together. So here we have squares and diamond or triangles and hexagons and triangles, and they're going to tessellate the plane. And we call that a semi-regular tessellation. In addition, irregular tessellations are patterns that repeat over and over again that are made from curved lines or irregular shapes. So we have these little cat-like things here, or wigs, or whatever you want to call this, showing here. And then over here we have a bunch of rhinoceroses. And these are still considered tessellations because there's no gaps and there's perfect alignment of all these shapes, and they're covering the entire plane, right? And you may say there's little gaps up here, but if you take this rhinoceros, you could put it right there, and you could continue it upwards and to the left and down. Then we have tessellation. So this is a regular or a semi-regular tessellation, but we have shapes going in two different directions, which we'll look at reflections at next week. Oh, we got a bunch of Pegasi, I think is the plural, Pegasus. So we got a bunch of Pegasi here. I'm very beautiful of these white and red Pegasi tessellating in the plane. We got another regular tessellation, but using rotation. So these are using the shape and it's rotating around. It's the same shape all throughout the plane, just in a different orientation. And that's totally okay as well. Just a bunch of triangles tessellating the plane. Again, we have hexagons mixed with triangles or diamonds, making a semi-regular tessellation. And lastly, we got this irregular tessellation of frogs and fish tessellating the plane, right? If we look at that, all this, where we're getting a tessellation here, right? And that's beautiful. Now, going back to that one point where it says, if we look at a vertex, so that's a point where everything meets. So like if we look right here with the fish's mouth and the legs of the frogs and the tail and the fin, the angles of these all have to add up to 360 degrees. So this would be considered a vertex, and they have to all add up to 360. Same with here. If we look at this, and we know hexagons are 120 degrees, and triangles are 60, so this is 120, 60, 120, 60. And I knew that because these are regular shapes. That all adds up to 360 degrees, right? And we could go and look at any one of our shapes here, right? If we go back here and look at the squares, we know the angles of a square is 90 degrees. So 90 plus 90 plus 90 plus 90 is 360. So that will tessellate. So if I give you an example like these, which one of these will tessellate the plane? If we know that the interior angle has to add up to 360. Well, we already looked at triangles and we know, well, if you have 6 triangles, then you get 360 degrees. So a triangle will tessellate the plane. We know squares will tessellate the plane because if you have 4 squares, that adds up to 360. So that's going to tessellate the plane. Here we have hexagons, which is 120. So 3 of these will add up to 360. So that's going to tessellate the plane. And I could physically do these. And then pentagon will not, because 108 times 3 is 324, or 432 if you have 4 of them. So this does not add up to 360. So a pentagon will not tessellate the plane. And we saw that earlier in this slide right here, right, where 3 pentagons will not tessellate the plane. So what about these other shapes? 144 degrees, can we put that into 360? Yeah, you're right. We cannot, right? And if I try this, so that's a 10-sided shape, and I could create a 10-sided shape and try to tessellate the plane with it. And it's not gonna work, especially because my computer is super slow. And right away, you could already see, without me doing a lot of work on this, that there's no way I'm going to fit these together to make or have no gaps. Okay, so 10-sided polygon, regular polygon, will not tessellate. Well, octagons we've already looked at, right? And if you, they will not tessellate. But what happens when we put 4 of them together? If we put these together, like so, we get almost a tessellation, but we get this really neat shape inside a square that we could tessellate with. So this would form a semi-regular tessellation, but it cannot tessellate just by itself. And lastly, if we look at a 12-sided shape, 150 degrees, that does not go into 360. However, similar to the octagon, we get this diamond shape in the middle. So we get this diamond or this star type thing in the middle. So it cannot tessellate the plane by itself, but it could create a semi-regular tessellation. Now, you might ask, how do I get these numbers inside? There's this formula right here that will be handy for you to know, is 180 degrees times the side length minus 2. So the number of sides, not the side length, the number of sides of the regular polygon, minus 2 divided by the number of sides. So if you take a regular triangle with 3 sides, you go 180 times 3 minus 2, which is 1, so 180 divided by 3, which equals 60 degrees. And sure enough, a regular triangle has a 60-degree angle. What about this shape? This is an irregular shape. What is the, will this be able to tessellate the plane or not? Explain why. Yeah, you're right. We cannot tessellate the plane with this. And I have an image right here, right? Because if we take 96 degrees and we try to line up the sides, we get over and over and over. But then over this one is overlapping, so it's not able to tessellate, right? So, and if we add up 96 plus 96 plus 96 plus 96 equals 384 degrees, which does not equal 360. So it cannot tessellate, right? So this next part, I have a shape already made here. So we have um, an irregular, what is this? 1, 2, 3, 4, 5, 6 hexagon. And this will still tessellate the plane, as you see down here. I just made the colors to line up there. Because 105 plus 130 plus 125 all add up to 360 degrees, right there. Now, or 120 plus 120 plus 120 add to 360. So that will tessellate. What about this shape here? Will that tessellate the plane? And if I copy this shape, I don't know if there's a parallelogram in a shape, probably, but let's just, yeah, and the answer is yes, this will tessellate the plane, right? If I have this shape here, right, very quickly, some of these shapes are very obvious, right? This shape's a little less obvious, but as soon as I start fitting these together, they fit very nicely, right? And then I could continue doing this, but this all adds up to 360. 120 plus 60 plus 120 plus 60. Now, a little fun fact about parallelograms, not parallelograms, four-sided shapes or quadrilaterals, all quadrilaterals will tessellate the plane. And let me show you. I can make a funky, if this works, I can make a funky shaped quadrilateral. Let's go something like this. And I might ask, does this tessellate the plane? And it might not be obvious right now, but yes, it will. Does anybody know why this is gonna, all four or quadrilaterals will tessellate the plane? Yeah, you're right. Because all quadrilaterals have interior angles that add up to 360 degrees. And 360 degrees is kind of the magic number for tessellations, right? And I could continue fitting these in and so on and so forth to get a nice, neat shape or tessellation, right? You could put another one up here and then it fits in. So that's a neat fact about quadrilaterals. And if we look at this triangle, this will also tessellate the plane. All triangles are another shape that tessellates the plane. So lastly, if we look at this here, I'm going to give you a graph like this on your assignment. This will be very similar. You'll be able to um, with this, watching this video, you should be able to answer all these questions already, because I pretty much answered all these questions already for you. For the regular shapes, you could use this formula back here. If it loads, there you go, this formula to solve for that. I hope this helps with your assignment. If you have any questions, feel free to email me. Take care.